All right, here we go. We are recording. We are correcting lesson 2.9 in our homework from Friday. One thing to make sure of is on that bar graph on the bottom, hopefully you read the directions because it says to give your graph a title, labels, and a scale. If you did not include all of those things, then you would lose points on those, okay? Your drawing needs to have a title. It needs to have labels. The labels are on the side. And it needs to have a scale, which means your numbers here should have a certain spacing between them. Thank you, Sydney. Ashlyn, I see your hand is up.
For number 2, I did the numbers of them. I didn't say the dog name.
So again, you got to make sure that you're reading the question closely because it says list the puppies in order, okay? So, because there are times when you will lose points or you'll miss them if you're not listing what is being asked to list. If it wanted the numbers, it would have said list the weights of the puppies, okay? Other questions on this side? All right, let's take a look at the other side. Oh, I forgot to finish again. Oh, no, I didn't forget to finish. It's just that everybody would have written a different problem for that bottom one. I did mess up. Luckily, I was still working on this with other people online because I didn't estimate these the first time I did them. And I did show you guys a couple different ways you could estimate. Like for number 10, you could have come up with an answer of 20 or an answer of 15. Either one of those I would accept. It just depends on what place you round to. Morgan, question?
The question was for number 5 on the last one. For the title, you put rainfall amounts instead of just rainfall.
Perfect. Much more descriptive than mine. And then, like I said, I didn't write a question for stretch your thinking because it does no good for you to check yours with mine because we all would have come up with different two-step word problems. Any other questions on this page?
No, I'm good.
All right, let's take out our student activity book. We're on the ever so amazing math procedures lesson, the word problem lesson. So lesson 210, I'm on page 57 in my math book. Give you a minute to get your math book out and get opened up to page 57. Since we're on this lesson, that also should give you a heads up that we are almost to our unit test. We should be taking our test on Thursday of this week. So make sure if you're still confused on things that you're asking questions, okay? All right, can I have a volunteer to go ahead and just start reading for me?
To describe
and our solar system. To describe distances on Earth, you do not need to use units of measure greater than thousands of miles. In space, however, distances are vast, and greater units of measure are used to describe those distances.
Good. So yeah, so think about that. On Earth, we don't really need to talk about things in more than thousands of miles because we're not comparing great, big, huge, ginormous distances between things. Really, we probably use more just hundreds of miles, if even that, when we're talking about distances between things. But when we get into space, holy schmoly, there are ginormous distances between planets. So you would have thousands and thousands and thousands of miles. So thousands of miles doesn't really work to describe the distances between the planets. So what do we do? Morgan, was that you who also started to read?
No.
No, someone else started reading when Jackson was reading.
I was Jasmine.
Okay, go for it.
Scientists express the distances in astronomical units. 1 AU is the distance from the Earth to our sun, which is about 93 million miles. 1 AU equals 93 million miles.
Okay, that's a lot of miles, right? A lot of miles. And think about it. So AU means astronomical units, right? When we talk about like miles, we would just use MI. But when we're talking about astronomical units, we're using AU. And the way that they determined how much one astronomical unit is they measure the distance between Earth and the sun. So from Earth to the sun, that was the standard. That was 1 astronomical unit. And 1 astronomical unit was 93 million miles. All right, someone else to read that next one.
When you work with distances in our solar system, it is easier to add and subtract astronomical units than it is to add and subtract numbers in the millions.
Yep, because you have less places you need to worry about, right? All right, so let's take a look at 2 of these planets. So remember, we're talking about distance to the sun. And so from Earth, which is right here, to the sun, it was 1 astronomical unit. But if we're looking at Mercury and Venus, do you think those are going to be more than an astronomical unit or less than an astronomical unit?
Less.
Less than 1
Much
astronomical
less.
unit, because they're closer to the sun than Earth is. And if Earth is 1, those are going to be less than 1. What about all of the other planets going this way?
They're gonna be like 2 times more.
They're going to be greater than 1 astronomical unit, right? Because here is 1, and then if we're going this way on our number line, they're getting bigger. And when we go this way on our number line, they're getting smaller. All right, so somebody read me question number 1 who has not read yet.
Venus orbits 0 and 72 AU from the Sun. Mercury's orbit is 0 and 33 hundredths AU closer. Explain why subtraction is used to find the distance of Mercury's orbit from the Sun, then find the distance.
All right, so does anybody want to share an idea of that? Why do they think that we're using subtraction?
Because
Kind of a tough question.
Because Mercury's orbit is closer to the sun than Venus, but they don't know where Mercury's orbit is. They do know that it's 33.8 astronomical units closer to the sun than Venus is, so they have to subtract to find out the distance.
I love it.
Well,
That's awesome.
Yeah,
Jaslyn, did you want to add?
yeah, they have to subtract it because Mercury is closer and Venus is further. So it said it's blah blah blah. It says that it was 0 and 33 AUs closer. So that means that you have to subtract to find out how much, well, how far Mercury is from the sun.
Okay, good. And I might even just, to shorten that up a bit, I might even say that we are just comparing Mercury to Venus. So we use subtraction. once you've written down why, your explanation why we're using subtraction, go ahead and subtract those two and then send me your answer in the chat. Subtract those two distances and send me your answer in the chat. Remember, when we're adding and subtracting decimals, we have to line up those decimal points. Right, I've got 3 answers, but none of you put any units on your answer. Oh, there we go. Good job. Now I have some units. All right. I'm glad you're positive. All right, so I'm going to put my 7200s on top. I'm going to line up my decimals and my place values. I'm going to put my 3300s on the bottom, and I'm subtracting. I can't take 3 away from 2, so I have to borrow, right? I can't take 3 away from 2, so I have to borrow. My 2 is going to become a 12. My 7 is going to become a 6. 12 minus 3 is 9. 6 minus 3 is 3. Bring my decimal down, add my 0. So 3900ths astronomical units would be my answer. Okay. Some of you are coming up with some different answers. Check your work with mine. All right, let's take a look at the back side. Can I have somebody new go ahead and start reading? I don't know, what is he doing?
The table below shows the distance in astronomical units of the planets from our sun. Since the planets Mercury and Venus are closer to the sun than Earth, their distance from the sun is less than 1 AU. Outer planets such as Jupiter and Neptune have distances greater than 1 AU.
Awesome. So we've got our chart here with those distances. And just like we were saying when we were talking about it, Venus and Mercury are both less than 1 because they're closer to the sun than Earth is. But everything from Mars to Neptune is greater than 1 because they're farther away from the sun than Earth is. Again, remember, Earth is that like token measurement. They're 1, and then everything else is based off of Earth. All right, let's go ahead and compute some distances between planets using our chart. So compute the distance between Venus and Earth. So Venus is 7200ths, Earth is 1. Am I going to add or subtract here?
Subtract.
I'm going to subtract. So Earth is 1, Venus is 72. Is that right?
Yeah.
Oh, line up the decimal.
No, you gotta line them
I didn't
up.
line up my decimals. Oh, okay. Shoot. I need to put that over farther the other way. Put my decimal and then line up my decimals like that. Now I can subtract. So 2 from nothing is just 2, right? Since there's nothing up above here, I just put a 2 down below.
No, you're subtracting, so you have to borrow.
No, I need to add a 0 there to cover up that 2, right? I need to add that 0. Now I need to subtract. So I can't do 2 from 0. So my 0 is going to become a 10, and this 10 is going to drop down to a 9. 10 take away 2 is 8, 9 take away 7 is 2, bring my decimal down, and a 0. 2800ths astronomical units. Okay. You guys go ahead and do number 3 on your own. Send me your answer in the chat.
We got to do a lesson.
Think about which number you're going to put on top. just because it says Earth first does not necessarily mean that Earth is going to be the number I put on top.
Can you point to the
Good, Landon. I like how you even used your label. Good, Ben.
Can you point to the ball that's different? Good job. There we go. That's Libby.
There they come. Awesome. Yes, yes, yes. So Mars is 1 5/10. Earth is just 1. When I subtract, I just have 5/10 as my answer. Figure out Jupiter and Saturn. Let's see, Jupiter, there they go. The answers are rolling in. Saturn is 9.5. Jupiter is 5 2/10. Subtract those. I get 4 3/10. And do the last one, Mercury and Neptune. Ooh, that's a big difference. Oh, we got to make sure we're lining up our decimals on this one too, right? Should look like that when you write it up. Got to cover up that 9 with a 0. I see a couple different answers coming through. Yikes, 3 different answers. 4 different answers. All right. So some of you, real quick, just again, the skill of looking back at your answer and seeing if it's reasonable is huge. I saw some answers come through that were, I'm trying to find a place to write it, were 30 and 29 hundredths. If you get an answer like this, you need to ask yourself, is this answer reasonable? And I'm going to tell you why it's not reasonable, okay? Our larger number is 30 and 1/10. Is 30 and 29 hundredths larger than 30 and 1/10 or smaller than 30 and 1/10?
Larger.
Larger.
It's larger. And if I'm doing subtraction, should I have an answer that's larger than one of my, they're called subtrahends, than one of those numbers I'm subtracting?
No.
No. So if your answer is bigger than the number that your biggest number in your subtraction problem, that should be like bells and whistles going off. Oh my goodness, something's wrong, try again, okay? So if you get an answer that's bigger than your top number when you're subtracting, try it again. All right, 9 from 0, I can't do 9 from 0, so I need to borrow. That becomes a 10, that 1 becomes a 0. 10 minus 9 is 1. 3 from 0, I can't do 3 from 0. That becomes a 10, my 30 becomes a 29. 3 from 10 is 7, bring my decimal down, I have my 29. 29 and 71 hundredths astronomical units, okay? I think those of you that had this, oh, I'm not even sure, you kind of set it up backward or upside down, but you still came out with your 30, okay?
Yeah.
So just make sure you're taking that minute once you have your answer to look back and be like, does my answer make sense? Okay, does my answer make sense? Right, Mercury's orbital distance in astronomical units from the sun as a fraction. So Mercury was 39 hundredths. How do we write that as a fraction? How do we say it? We said 39 hundredths, right? 9 hundredths. So 39 hundredths. Okay. That's how we write it as a fraction. We look at how we say it, and then we write what we say. We're going to skip number 7. Okay, no need to do number 7. All right, let's take a look at our homework real quick. Here's your guys' favorite parts, right? Homework side of lesson 210.
Guess who I have on my shirt? Who's that on my shirt?
Okay, we don't have to do the homework side. We're not doing page 45 today. We are just doing the back practice side. That's the remembering side of our homework. So let's go ahead and take out our planners.